Have you ever looked up to the sky and imagined a future in which our species are interplanetary, where we travel from world to world? Well, colonizing planets is probably the first step to that. And in this video, I want to explore that. Hello, my name is Anthony, and in this video, we're going to explore the possibilities of colonizing Mars. Now, colonizing Mars is extremely complicated. There's so many variables and so many things that have to be considered, innovations, things that have to be created. It's too complicated for just one video, and this video is not going to contain everything. I may jump over a couple of details and things like that. So if you're planning on making a trip to Mars, don't just watch this video, go ahead and check out some other videos and do some more research. But I'm just going to go over some of the most important things and impactful things to begin colonizing Mars. Okay, so what's Mars? Well, you probably already know that it's a planet, and it's the fourth planet from the sun in our solar system. But let's take a look at some additional facts about Mars. The red color on Mars comes from iron oxide. Mars is the second smallest planet in the solar system with a diameter of only 6,700 kilometers. And the temperature on Mars ranges from 20 degrees Celsius to negative 140 degrees Celsius, with an average of about negative 60 degrees Celsius. The days on Mars are barely longer than the days on Earth by 24 hours and 37 minutes. However, the years are almost twice as long. There is water on Mars as polar caps, but they can't be melted. Because of the thin atmosphere on Mars, if you were to melt this ice, it would turn directly from solid to a gas. The atmosphere on Mars is 1% of Earth's. Okay, so let's begin to consider the process of colonizing Mars and maybe even terraforming it. The first step would be to set up communications with Mars. Now, it's already been done. You can communicate with Mars. However, more can be done by setting satellites around the sun to be able to communicate with Mars all year round. The second step would be to survey the land and figure out where would be the best place to land. We can't just go willy-nilly and drop wherever we want, because it could likely be fatal. We don't know what is where, and we need to be strategic about where we land to have the best possibility of survival. Surveying the land hasn't really been done yet, and there's a lot more that has to be done because, well, the only things we've taken so far are the rovers, and Curiosity rover only travels about 5 miles per year, or about 8 kilometers. It's not a lot, and it's far from enough. The third step would be to prepare. And by prepare, I mean prepare for humans to go. We can't just go right away because we probably wouldn't have the infrastructure that we would require to survive. So we first need to prepare Mars for humans. And being very optimistic, we could probably accomplish this within a decade, but that's pretty unlikely. To begin, we will need energy on Mars. And that's a problem because Mars is very energy poor. Since it is further away from the sun as Earth is, it only receives about half as much solar energy. So solar energy won't work because, in addition to only receiving half as much energy, sandstorms usually cover up and don't allow it to receive any energy. So solar on its own is not enough. Some of the other options is geothermal and wind, which won't work either. Wind because the atmosphere is so thin, it wouldn't work, and geothermal because the planet is far too cold. So in the beginning, the only viable option is probably going to be nuclear energy. However, this comes with its own problems because there isn't really radioactive material on Mars, so fuel will have to be transported from Earth in order to run these reactors, as well as the reactor itself has to be brought from Earth. However, if we were to set this up, we could run a small outpost for a couple of years. Okay, with the power situation solved, we have to move on to habitats, which also have to be prepared beforehand for humans to arrive to. First of all, Mars is cold as heck. If you remember, the average temperature is negative 60 degrees Celsius. That is too low for a human to survive. So in order to survive, we would need some way to heat our environment inside of wherever we may be living, our habitats, and maintain our suits warm enough to survive. This would be very energy intensive, but it's possible. However, there's other solutions that might be better. Many have considered sending hydrogen bombs to Mars in order to heat up the planet and create a denser atmosphere. However, this isn't a great option. Another option is to pull asteroids into the planet and have them crash. A lot of asteroids contain certain gases and would likely cause explosions that would heat up the planet. However, after running the numbers, it's clear that it's way too many asteroids and it's outside of the realm of possibility, at least with the technology we have now. So what can we do? Well, humans actually already know how to warm up planets. In fact, we're doing it right here on this planet right now. By burning fossil fuels, we're putting carbon dioxide into the air, which is causing a greenhouse effect. Sun is coming in, but it's having a hard time getting back out. So is it possible that we can set up plants in Mars to burn fossil fuels and create this greenhouse effect that heats up the planet? Well, no, not really. It's not possible because it would require far too much to create the atmosphere required to heat up the planet. It would take thousands of years, even if we could take the fossil fuels, because there's not really any fossil fuels on Mars. It would have to be taken from Earth, which is far too expensive, far too difficult. However, that's not the only solution. It's not only carbon dioxide that causes this greenhouse effect. There are other gases that are actually even more potent than carbon dioxide that could heat up the planet faster. And luckily for us, one of the most potent gases that causes a super greenhouse effect is sulfur and fluorine, both of which are contained in the Mars soil. So we can imagine some plants on Mars that suck up Mars air and through a chemical process mix it with sulfur and fluorine. And this mixture is thousands of times more effective than carbon dioxide in creating this effect. So this is really a possibility, and we could possibly heat up Mars to a sustainable temperature for humans. Okay, so Mars is now warm enough to sustain human life. So what's next? Well, next is housing or habitats. So some of the best options right now is sending massive 3D printers that scoop up Mars dirt, make this mixture, and build houses completely autonomously. This is great. So if this works, this could be potentially a solution for building habitats. However, then there's the situation with being able to breathe, right? So we also will have to take from Earth nitrogen and oxygen to be able to create an atmosphere inside of these habitats in order to breathe. However, if you thought that was it, you're wrong. There is a lot more that is trying to obliterate human life. Next thing to worry about is radiation. Mars doesn't have an atmosphere or a magnetosphere either. That means that half of the radiation that passes through Mars reaches the ground. This is 50 times more radiation than on Earth. This would increase the risk of cancer and, well, it wouldn't be good for the health of astronauts, obviously. So in order to slow the rate of exposure to radiation, we could cover the habitats with a layer of nitrogen, which can be harvested directly from Mars. Additionally, there could be a thick layer of mud or Mars dirt over the habitats, and this would reduce the radiation reaching the people. Not completely, but drastically. Okay, so now we have power on Mars, we have habitats, and the planet's warm enough to survive. Next, it's time to make the journey to Mars. That's right, it's time to send humans. Okay, this is the point where, there's a lot of details missing. Obviously, there's so much more that goes into this. You gotta send parts and resources and a whole bunch of other stuff before you send the humans, because you really don't want them to die. So yeah, there's a lot more that goes into that, but, it's just the most important things. So we're sending humans now, okay? Once humans arrive to Mars, they'll be spending most of their time indoors. So they'll have to take, robots and remote control vehicles that they can control from inside the habitats, because you want to reduce the amount of radiation that they're receiving, in addition to the fact that Mars dust is very fine and electrostatic. That means it sticks to the suit and it would be introduced into the habitats, which is really bad because it is toxic. That's right, it contains perchloric salt. I don't know if I'm saying that right, but this is toxic, and exposure to this over time would kill you. For this reason, you wouldn't really want to go out too much, the radiation and the dust, apart from other dangers that we're not really sure about yet. So that's the thing. However, the dust situation could be solved with a system in which the suit stays outside of the habitat at all times, connects through a hatch in the back, and you come out of the hatch. This way, the suit would not really ever be going into the habitat, and much less dirt would be introduced into the habitat. Okay, so now we have the issue of sustenance, because unfortunately humans have to eat and drink water. Water is easy because you have the ice caps. Now, you can't unfreeze that in the atmosphere of Mars because, as I mentioned earlier, it turns straight into a gas. However, if you bring that ice into the synthetic atmosphere that was created for the humans to be able to breathe, and then you melt it, it will turn into water. So easy peasy. You have water already on Mars, you just get it straight from there. But then there's food, which is a little harder. Growing plants on Mars, on the dirt of Mars, on the soil of Mars, is not really a good option because it lacks the nitrogen that is necessary for plants to grow. However, it could be processed and decontaminated through a complex and expensive system straight on Mars, and then fertilized with organic waste, aka poop. It's not a great option. A better option is hydroponics. With this system, you'd be able to grow a variety of plants and fish at the same time. This would also improve the health of the astronauts, having variety and fresh food. It's just, an additional thing for, people that are on another planet that's threatening to kill them every second that they're alive. So that's a good thing. So for now, with the current technology, this hydroponics is probably one of the best solutions we have right now. Another thing is that the gravity on Mars is 1/3 of the gravity on Earth. This is a problem. You may have heard of this already from the astronauts that are on the International Space Station, but muscles decay. That's right, the muscles would begin to waste away, bone density would start to reduce, and people would begin to likely have cardiovascular issues. Right now, there isn't really a solution that would be ideal. So for now, astronauts would have to do a lot of exercise every single day in order to slow down that process. It wouldn't completely slow it down 100%, but it would help enough. However, in the future, the possibility exists of a rotating habitat in which it creates its own gravity. For now, that's not really a possibility, but it likely will be in the future. Anyway, Mars will require a constant flow of resources from Earth, taking fuel for the reactors, resources, tools, materials, and other parts for the equipment that they're using on Mars. And this is a problem because you can only go to Mars every 2 years. That's right. There's a window in which you can go to Mars every 2 years, but any time in between that, you are disconnected and you can't really go. So if something were to happen to the astronauts where they required assistance immediately and you're not close to that window, it could be a serious problem and they could potentially die because of this. Anyway, I'm optimistic for figuring it out. I believe that eventually Mars will be terraformed and it will be the beginning of far more in our interplanetary journey as a species. Anyway, thanks for watching. I hope you enjoyed this video. I really enjoy making things like this and I would like to continue to do it. So if you guys can support me and subscribe, I'd really appreciate that. And I'll see you guys next time.